Now we start another example. We are given the function f of x is equal to x power 2 over 3. We are asked to find where is this function increasing, the intervals on which the function is increasing or the intervals on which the function is decreasing, and to find the relative extrema. So usually we start the first step finding the domain of the function. What is the domain of this function? This function is having a domain which is all real numbers, as we see. Now, next, what is the first derivative of this function? F prime of x equals 2 over 3 x power 2 over 3 minus 1. So it's equal to 2 over 3 x power minus 1 over 3. We can rewrite this f prime of x as 2 over 3 into cube root of x. As we see, f prime can never be 0, is not 0 for all x. As I said in the previous example, when you have a fraction which is equal to 0, the 0 is always coming from the numerator, and our numerator is 2, so this can never be 0. But we notice that at x equals 0, f prime of x is undefined. And when we talk about a value for x, which makes the first derivative undefined, I call it critical value if it is in the domain of the original function. And we said the domain of the original function is all real lines. So this is in the domain of the original function. And it makes the first derivative undefined. So then x equals 0 is a critical value. What should we do next? We should go to the real line, put the 0 on the real line, the x equals 0. It splits the real line into interval 1 and interval 2. We should study the sign of the first derivative. Of course, we all agree that the first derivative, f prime, is equal to positive in the numerator, but a cube root in the denominator. And here I have positive over a cube root. The sign to the left of 0, anything less than 0 is negative, so the cube root of anything negative will be also negative, so it tells us that here f prime is less than 0. So on this interval, wherever you go, whatever value you take, the first derivative will be less than 0. On the interval from 0 to infinity, we have values of x to be positive, so this will make the first derivative positive everywhere on this interval. So I have f prime greater than 0. F prime greater than 0 tells us that the function is increasing. Here tells us that the function is decreasing. So the intervals on which the function is increasing or decreasing, I will put them here. From minus infinity to 0, we have f is decreasing. The first derivative is 0, is less than 0, decreasing. While on the interval from 0 to infinity, f is increasing. Now we see decreasing on this interval and then increasing, then it reached at x equals 0, f of x has what? Minimum, of course, because it is decreasing and then it's increasing, has a relative minimum. What is the value of this minimum, what is f minimum? In order to find f minimum, you go to the original function and substitute 0, okay? So here in our case, it is equal to 0. So we found the critical value. We found the intervals on which the function is increasing, the intervals on which the function is decreasing, and we also found the minimum value. And that's it for this example. F of x equals x squared, 2x squared, minus x power 4. And I will ask you to sketch. I'm not asking you to put values for x and find the corresponding values of f of x. No, we need to sketch. The first thing we need in sketching is to find the intercepts. This is the first thing you should think of. So, in order to find the y-intercept, you should put x equals 0. When x equals 0, the y-intercept, you substitute here 0 and 0, of course you will get y equals 0. This is the first thing. What about the x-intercept? When you say x-intercept, you say, what are the values of x which makes y equals 0? So you go up and say, 2x squared minus x power 4 equals 0. So take the x squared common factor. I have 2 minus x squared equals 0. Now I have these possibilities, either x equals 0, x equals minus root 2, x equals plus root 2. This was the first thing. Our mission to find the intercepts is completed. Next, we need to find the intervals on which f of x is increasing or decreasing. In order to find the intervals on which the function is increasing or decreasing, of course, we should find f prime of x. F prime of x equals 4x minus 4x cubed. Notice that I'm differentiating. 2 times 2 is 4. X squared will be x. Here, 4x cubed is the derivative of x power 4. Now I will say, what are the values x for which f of x equals 0? So 4x minus 4x cubed equals 0. This implies that I have 4x. If I take it common factor, I have here 1 minus x squared. This implies that we have 3 possibilities, either x equals 0, x equals 1, x equals minus 1. Okay. Are all these values in the domain of the original function? Yes, because the original function is a polynomial, the domain of any polynomial is all real lines. So all of them belong to domain of the original function, okay? Now, what should we do next? Yes, we should go to the real line. If I go to the real line, I will put 0, minus 1, and 1. And I will start studying the sign of the first derivative. We can see that the first derivative can be rewritten as 4x into 1 minus x squared. This is equal to 4x into 1 minus x into 1 plus x. So the first derivative is a product of 3 things which might change in sign. The first thing, the second thing, the third thing. This is again first, second, third. First, second, third. And in this interval, first, second, and third thing. And then I start studying the sign in each interval. In the interval from minus infinity to minus 1. Pick any value in this interval. Somebody will take minus 2, somebody will take minus 3, somebody will take minus 5,000. It doesn't matter the value. All what matters for all of us that we should get the same sign. If I put here minus 2, I will get minus. 1 minus minus 2 is 1 plus 2. Again, this is plus. 1 minus 2 is minus. So this is a positive. On this interval, the first derivative is greater than 0. So the function f of x is increasing. Now in the interval between -1 and 0, let's take minus half. Again, if I put minus half here, I get a minus sign. 1 minus minus half is plus. 1 minus half is again plus. So the whole thing is negative, and I have minus, 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 minus here. The first derivative is negative, so the function is decreasing. Now, in the interval from 0 to 1, take half. Half is positive. 1 minus half is positive. 1 plus half is positive. Again, positive, positive, positive. So the first derivative is positive on this part. So the function is increasing because f prime is greater than 0. Again, we do the same thing to the right of 1. Get me any value bigger than 1. Let's say 2, 20, 200. 2 is positive. 1 minus 2 is negative. 1 plus 2 is positive. So this is a minus sign. So anywhere here, the first derivative is less than 0. So the function is decreasing. So now we saw the intervals on which the function is increasing and decreasing. Now we should talk about the -1, the 0, and the 1. These are the critical values of our function. We can see that the function is increasing and then decreasing at x equals -1. F has relative maximum. Again, increased and then it decreased. What is f maximum? What is f maximum? It is equal to f of -1. Again, we do the same thing. At x equals 0, f has a relative minimum. We can see that the function is decreasing and then it is increasing. F has relative minimum. F minimum equals f of 0. At x equals 1, we see that the function is increasing and then decreasing. F has relative maximum. So f maximum equals f of 1. If we go and substitute by -1 in the original function, you will get the value 1. So we have -1 and 1. This is maximum point, relative maximum. Here, if we substitute by 0, this is equal to 0. We get 0 and 0 minimum, relative minimum point. And then we take the 1 again to the original function and we substitute, we will get a 1. So we have the point 1 and 1 to be relative maximum here. Here I write relative minimum and here relative maximum. So now we need to put everything on the xy plane to sketch this function. So we will do this here in the last part. Okay, we see that here I put in front of you the x and y axes, and I'm trying to expect the terminal ends of this function. I can see it is x power 4, so it should have something like a U shape. Open upwards or downwards depends on this sign, the sign of the leading coefficient. So we are expecting our end terms to be in this part because we have minus as a leading coefficient, okay? And there is something happening in between, but the two terminal ends of the curve should be on the same side, either up or down, depending on the sign of the leading coefficient. Now, next, what should we do? We should put the intercepts on the plane. We should put also the maximum and the minimum. Here I have the x and y intercept here. This is the y-intercept. What about the x-intercept? The curve cuts the axes at minus root 2 and positive root 2. And I will put the 1 here and the 1 here. Here is minus 1 and here is positive 1. So now I drew the terminal ends and the intercepts. Good. Next, what should we put the maximum, minimum values? At x equals minus 1, y equals 1, and we have a relative maximum. So this is y equals 1, 2, هنا 1, وهنا minus 1, minus 2. So at minus 1, we have a maximum value. A maximum value tells us that I should make a small cap here because it tells us that there is a maximum. And then at 0 and 0, I should make a small cap here like this because it tells us that there is a minimum. Again, at 1 and 1, there is also a maximum value. So I will make the cap this way. Can we see all these? Now we start connecting everything together. I will connect everything with this nice gray color. This terminal end tells us the function is increasing to the left from this terminal end. Having that the function is increasing from minus infinity to minus 1, we start increasing until we reach minus at the point minus 1 and 1, where we have a maximum, and then between minus 1 and 0, it decreases, so it will go down. And then from 0, it reaches the minimum. We go upwards after the 0, we go up, see the gray color, until we reach the maximum value we have at 1 and 1. And then we start, after 1, to the right of 1, we start to decrease, where we cut the x-axis and we go to the terminal end as we see here. Okay, so this is how our curve will look like after sketching all the information we got. Thank you very much.